Alright, so welcome back again. My name is Jesse, and in this wonderful and exciting tutorial, we're trying to see how to visualize our word embeddings using a very nice tool called Whatlies. So Whatlies is a very powerful NLP Python tool that allows us to be able to understand what lies within a word embedding. So let's see how to work with it. So this is a tool, a very nice library created by Rasa. Let's see how to work with it. So in case you don't have it, you can just install it with this option. So pip install Whatlies. So I'll go back to my terminal. Then I will install it here. So pip install Whatlies, right? It's having a lot of back support for several backends, so you can install them accordingly. Perfect. So let's come back again. Let's see. So it gives you the option of working with some very powerful NLP libraries like Spacy, right? So this is a backend support for Spacy, for fast test, for Gensem, for transformers from Hugging Face, SensiTiveVec, and then TensorFlow and the rest. So let's see how to work with this particular package. So before we move on, let's understand what we mean by word embeddings. So word embedding simply is how we represent text, right, in numerical arrays, right? So it's just a learned representation for text where words that have the same meaning have similar representation, and a representation here is a numerical representation of that particular text using an array or a vector of numbers, right? So there are several ways we can do that. We can use the frequency-based approach, in which I counted the occurrence of the word, count vectorizer, or TF-ID vectorizer, or we can use co-occurrence. There's also the prediction-based, that is the usage of word to vec, in which we have cbow and skipgram, which are trying to predict the probability of a word given a context, or the other way around. Let's see how to create an embedding using this wonderful tool called Whatlies. So I'm going to load the package. So it's going to be my package I'm loading. So import Whatlies, right? So that's the package we're trying to see. And let's check the various things we can do with this particular package. It's going to be the methods and then the attributes. This is useful to help you know what we have in this particular package. So there we have my Whatlies, right? So with Whatlies, you can do some things. You can check for the embedding, right? So we have two main subclass here. We have the embedding that allows us to be able to work with individual embeddings to create your own word embedding. We also have the embedding set, which is a collection of words, right? So let's see how to work with the first one, then later we'll see how to work with the second one. So I'll come back again and I'm going to create my simple embedding. So making a word embedding. So every word embedding must have, let's say, a name, right? And then the vector, right? The vector is the numbers, an array of numbers that are used to represent that particular stuff, right? So you can actually create your own embedding. It's going to be, let's give it as, let's say, water, right? That's the example you're trying to work on. So let me pick it like this. This was something we're trying to check on later. So let me bring this one down. So I'm trying to pick a simple word, right? As we already know, picking a simple word, and I'm trying to see how to create a word embedding for that particular one. So we have water, right? So water is going to be the variable. I'm going to create my embedding for water, which is going to be the name, right? As I said, it takes the name and then the array or a vector of numbers that are used to represent it. So I'll give it my vector of numbers. So this can be any number, so 0.5, 0.5, right? So this is going to be a simple word embedding, right? So if I check for the type of it, if I go with this water, this is going to give us the class of embedding, and then this is the particular term there, right? Very simple. So every word embedding in which I've created using Whatlies is going to have this particular type. It's going to be my type of this word embedding. It's going to be my embedding, and this embedding is going to have a name and a vector. So to get the name of that particular word embedding, it's going to be my water.name. So this is going to give us the name of that particular word embedding, which is water. So this water here is the same word spelled here, right? That is the name. In case I want to get the vector, I can also come back again and then go with the same thing. This is going to be to get the vector, going to be my water.vector, right? So this is going to give us the vector of numbers. That is the one we inputted. Very simple. You can also plot this entire stuff in case you want to plot this particular word embedding, right? Which is very useful. Just do the same thing as this. So water.plot, right? Now pass in the particular type of plot I want to make. If I go with this option, it's going to just plot it perfectly for us, right? It has given us a very nice plot. So based on the dimensions given, which is 0.5, which is the vector array, it has plotted it in a vector space of 0.5 here and 0.5 here. Very simple. In case you also want to change this particular color to give it your own color and the rest, you can also do the same thing. So let's try that one out. This is going to be me plotting it with customization, right? So it's going to be very simple. So here's going to be the kind. I can specify that I want to get an arrow, and then I also want to give a color for that particular one. Let's say black. I give it any color. Then it's going to change the color. So here it gives us as blue, but if I customize the color and the rest, it's just giving us an arrow and the color as black, right? Very simple. That is something very simple you can do with this wonderful package. You can just create a simple embedding using this embed class, and you give it your vector, right? Perfect. Now let's do some other stuff with this. So we already know that water can be converted to different form, right? So I want to represent that same different types of water conversion in different format. So it's going to be like this. So let's try it with a word rep, right, of water. So we know that water, right? When there's water, there is also heat, and then there's cold, right? So if I have water and I add, let's say, I have water and I add heat to water, I'm going to get what? Steam, right? Or vapor. If I have water and I add cold to water, so water plus cold is going to give me an ice, right? So we can do something simple to help us represent this particular stuff that we have. So let's see how to do something similar with that. I'm going to create a word embedding for water, which I've already created. So it's going to be my embedding. We just be putting some random numbers there. So water, passing the 0.5 and then 0.5. I'm also going to create another one for, let's say, heat. So embedding, I spell embedding, embedding. I'm passing heat, right? Or fire, in how you call it. I'm going to give it my values, right? Right, so I've just created some simple random numbers. This is just off head, it's not correctly correct. Perfect. So I've created some simple word embeddings. Now in case I want to plot the entire stuff, right, and I actually plot the entire stuff in several ways. I can do this simple plot. So it's going to be the first plot, scatterplot, to see how it is in vector space. It's going to be for, let's say, I in my embedding. So it's going to be my water, and then my heat, and then there is cold, and then there is steam, and there is ice, right? I want to plot the entire stuff there. So I want to plot this stuff there, and I can see that, okay, I dot plot this particular stuff. I want to do a scatter plot, and if I do a scatter plot, I also want to get the test, right? So kind is equal to test. So this is a simple way you can actually plot the entire stuff. If I run it like that, it's going to give us a very nice plot behind the scene. Very cool. So based on this one, you can see that water is here, right? And then we have ice. So if it is, you know, like ice is closer to cold here, right? It is not correct, but we are just trying to help us understand the concept. So water is the highest. Then if it is close to, water is close to heat, it is going to give us steam. If water is close to cold here, it's going to give us what? Ice, right? So that is something simple that we can do. This is a simple way we can actually visualize our word embeddings. You can also use the arrow to help you with that. So this particular format of plotting. So let's try that one out. So this is going to be using an arrow to check the distance, right? So it's going to be very simple. So I can just go back again to the same thing we did above. So we had water, dot plot. Now specify the kind is going to be arrow. Then I'll specify and give it the color, which is going to be, let's say, black, right? Then I'll do the same thing for the rest. So let me copy and paste it and save us time. Right, so if I've copied and pasted, so if I run it again, it's going to give us a very nice plot of the entire stuff, right? So the same thing we did here, which was a scatter plot here, right? We can also have a simple plot here. You can see that from here we have water, which is here, steam. So steam is close to heat, right? So water, heat, giving us some very simple plots. So that is something very simple. You can also use cane, man, and all of these things, but it is just to show you the overview of how to work with Whatlies to help you see how to do some simple plots with Whatlies. So this allows us to see what lies within a word embedding. Now let's try it on some other aspect, right? So we're trying to try this same particular application on analyzing the word embeddings within this particular test using Spacy. So let's see how to do some simple high dimension plots using Spacy. So you can also use the backend language, so using the backend languages or backend tools, right? So So we'll be using Spacy for this particular time to help us do some simple stuff. So you have to make sure that you have Spacy already installed on your system. So let's try the first one. Try the first method one, right? This is the first method, then you try the second method. So let's see an example. So the first method is using Spacy. We'll be using normal Spacy. Then the next one, we can also use the SpacyLanguage to help us with that, right? So you can, any of them is going to work. So let's try the first one using Spacy. So I'll import Spacy. Right, then I'm going to create an NLP object. So NLP Spacy dot load. I pass in my model. So call web empty. We are using the medium, but we are using the medium model, right? So to download it, just go back to your terminal. Just go with this option here. So Python 3.7, any Python 3.7, that's M Spacy download, right? And you paste in there. So this is how to download the model. This is medium, right? The bigger size, not the smaller size. So you can actually do that. Then I'm running the same thing here. So it's going to create an NLP object behind the scene using Spacy. Then I can use this particular one to help me get the word embeddings and then visualize it. So let's analyze this particular test that we have here. We have this wonderful test here. So I'm going to be analyzing this test, right? So under normal conditions, water exists in the form of three phases. We have the solid phase or cold ice. We have the liquid phase, water, and the gaseous phase, heat, steam, right? Something simple to help us make it easy for us to understand. So I'm going to create a simple word tokens of the entire stuff. So go to my word tokens. Going to be the same thing. So for token test, I'm going to tokenize the entire stuff. So for token in my NLP object that we had, so my test, let's convert the entire stuff to lowercase, right? Something very simple. So I'm going to get all the entire stuff we have, this test that we had, as tokens as the first thing. I'm going to get the word embeddings for each and every one of them. So if I go back and I check for the word tokens here, so it's going to give us all the tokens within our test, right? Very simple. Now I want to get the word embeddings for each and every one of them. So how do I do that? So I can simply do that by looping through them and passing them through my embed option, just as we did above. So it can be the same thing that we did. It's going to be my tokens, which is going to be this option. So t.test, right? Then I'm going to pass it into my embedding. Remember that this embedding here is the same embedding that we did here, right? We created this embed. So we're just passing all the tests to this particular option here, right? That's the same thing you're trying to do here. So embed, right? And I'm going to pass in my test.tst and a vector, and a test.vector. So we are using Spacy's vector to help us with that. Then I'm going to, for say, t in my nlp.pipe, I'm passing my word token. So this is going to give us all the word vectors for the entire stuff. Hopefully it doesn't give us any mistake. I made a mistake somewhere. Let's fix it here. It's supposed to be test. Perfect. So we are done with it. If I go back and I check it out again, now it's going to give us all the words, right? And then their embeddings has given to us in the format of an embedding. So it's going to loop through this pre-trained word embedding model from Spacy and give us the word embedding for each and every one of these particular terms. And now I can actually plot the entire stuff. So in case I want to plot the entire stuff, I can plot it with this option. So let's give it at my x-axis. It's going to be the tokens that I have. So let's say I want to check for water, right? I want to check for water. Make sure that this particular word is there. So if I go back and I do this here, I come back and I check it here, we see that we have it as water. Water is part. I can get the vector of this particular one, right? I can get the vector of this one, and these are all the vectors of this particular token from the pre-trained model, right? Which is different from the one that we had initially made. So I'm going to plot this entire stuff. It's going to be my x-axis, then my y-axis. It's going to be my tokens. Let's say I want to do the same thing for ice, right? So ice and water, or you can make it cold and water, anyhow you want it to be. Then it's going to plot them out perfectly. So we're going to say for name and then t in tokens dot items. Remember this is a dictionary. Then I want to plot them out. So t dot plot x-axis. Let's go to my x. Yeah, the one that we have there. Then the same thing for the y-axis, which is going to be y as this, right? Perfect. Then I'm going to plot the entire stuff as we did above. So plot the kind. I'm going to test so that I'll be able to get a test itself. Then I'll do the same thing I did above here, but may copy this one here to make our work easier for us. Perfect. So that is also, let's plot it out. Hopefully it doesn't give us any mistakes and error. And as you can see, it has given us a very nice word vector or word embeddings visualization of this entire test. So you can see that ice is here and water is here, right? And code, the code is closer to ice, right? And then we cannot see some of them all, but we can make it better, right? You can actually use plt.show to make it bigger for you to be able to see it. Right, perfect. So this is how it's going to be. But in case I want to make it bigger, I can also use matplotlib. So let's do it simple. So I can just do it. This option here, I'm going to import matplotlib, and then I'm just going to copy the same thing that we have here. I'll copy this, and then you can just plot it out. So I'll copy this one. Then I want to make it a bigger, better plot, right? It's going to be this option. Copy this one here. Then in case I want to plot it well, to make it bigger and better, right, I can just come back again and do something like this. plt.figure. So fixed size 2010, right? Something like that. Then in case I want to plot the entire stuff, and just come down here, plt.show. So this is another way you can actually plot the entire stuff. It's going to give us a very nice bigger plot than the previous one above. So that is how to understand what lies within a test using Whatlies, right? Very nice package. You can see it's very clear, right? So water is here, and then water is far at this particular point. Ice is here, cold is close to ice, right? Heat, liquid, right? Very cool. Based on the word that you supply, very cool and very nice. So that is one of the ways you can actually work and plot the word embeddings within a test using Whatlies. Now let's see another alternative you can also use. So this was the first method using Spacy, right? Right, it's the first method. Let's try the next alternative using the simple lazy option. I call it lazy because this is just using the language option. So in this case, it's going to be method 2. It's going to be method 2. So the method 2 is that we are using this option. We are using a Spacy language. This is going to be using the backend, right? So in that case, it's going to be mine. So from Whatlies dot import embedding set. Remember we had embedding set previously. Then from Whatlies dot language import Spacy. So SpacyLanguage. So this particular option here allows us to be able to do a lot of things. We can actually also get I made a mistake somewhere. SpacyLanguage. I spelled it wrong. See what I spelled, language. Okay, perfect. So you can actually get all the languages. In case you want to get all the languages from this particular stuff, you can just do this option. So there, how first of all, let's import it first. So let's import this option here and get all the languages. So this is going to give us, so you have the byte per language, you have convert count vector language. These are all individual class that allows us to work with the backend. So fast test, Jensen, Hugging Face, and the rest, right? So we are using the Spacy on, right? You can use the rest per your tax. So let's try and see how to do that. So I'm going to specify my language. So language, which is going to be this option here, my Spacy language. Then I'm going to specify the model. So the model is going to be my web, and this is using Spacy's backend as backend. Then I'm going to specify the words I want to do. So the words I want to virtualize is going to be words like water, another word like ice, another word like, let's say, cold, and then steam, and then rest, right? Just as we had previously, right? So this is another way, right? So I'm just creating an array, right, or a list of words that I want to get the word embeddings for them. I'm using the backend from Spacy, right, to help us with that. Then in case I want to actually get the word embeddings, I can just do the same thing. So embed, go to my embedding set. So embedding set. Now pass in all the particular tokens there, right? It's going to be asterisk. We are using the magic from Python. So language, get that particular word. So this is going to help us get that particular word for that stuff, which is going to be this option. So for my word for W in the word, right? Right, apology for that. So this is going to be the simple word embeddings we are creating. So if I check this entire stuff that we have a lot of embed sets, right? So there's going to be a very nice embed set which you can naturally plot. So I can naturally plot this entire stuff. So embed set dot plot. You can also interactively plot the entire stuff, which is one nice cool stuff about it. Now specify the axis I want to plot. So let's say I want to plot the axis of put embedding. So all the embeddings that we had, all the embeddings we had here can still be found here. So if I go back and I do the embedding for, let's say, ice, I'm going to get the embedding there and get the vector. Going to give me the vectors, right, of it. So you can actually use the same thing to plot the entire stuff, right? Very cool. This is using the Spacy model. So I can specify that I want to get for ice. And I'll do the same thing for the one I want for the Y. So this is very useful in case you want to do more complex activities. So embed, then I'll pass in, let's say I want you to do for Steam. If I run it like this, now it's going to plot this interactively and compare them between them. So it uses what do we call it, behind the scenes. So that's one of the ways you can also work with it. It's using our tail plot, right? And you can see that it's given us a very nice plot that we can zoom in with some tooltip, right? Very cool. So that is one nice thing about this particular package. Very cool. We are comparing ice and steam, and you can see that heat, where steam is so far, right, and then ice is also so far. So snow and then cold is closer to ice, and then heat and then water and gas is closer to steam. So that is something very simple. It can help us to represent words, right, in vectors, in vector space. Very cool and very nice. Of course, there are lots of things you can also do, but these are some of them. So thank you for watching this tutorial. So the basic idea behind this wonderful tutorial is that you can use it individually, right, as an embedding, right, like this option here, in which you specify your text and your vector, or you can use the embedding set, right, which is what we did using the Spacy backend here, right. You can work with Spacy backend like this and get the embedding individually, or you can, and then you can also plot the entire stuff in vector space. Then you can also use this option here to help you get everything as expected, right? Very cool. You can zoom in, zoom out, you can save the entire stuff that we had, right? Very cool. So thank you for watching this tutorial. In case you have any question or contribution, you can just put it in the comment section below, and see you in the next session. I hope this has been insightful. See you. Bye. One more thing, you can even plot the similarity of the entire test that we have, right? In case you want to plot the similarity of all of these tests, you can also do the same thing with this for this embedding. So let's work on it. So it's going to be plot similarity, which is very important. I can just go with MB, right? Now specify that I want to plot the similarity between the tests that we had. So I'll give it a metric using the cosine similarity, cosine. Then if I run it, it's going to give us the similarity for the entire stuff. So that's one cool thing we can also do, right? You can see that it's giving us a very nice cosine similarity comparing the words. So you see that water, ice, cold, steam, heat, based on the word vectors, you can see the diagonal line for all of them, and then you can see how it works, right? Very cool. Very see that ice and cold are close together with different colors. So thank you for watching. See you another time. Baka.